This video will explain some of the most well-known machine learning algorithms in less than a minute, helping everyone to understand them. Number 1. Linear regression. One of the simplest machine learning algorithms out there, linear regression lets you predict continuous variables based on independent ones. A dependent variable is a value that can change depending on chance, so it's worth predicting because of how important its use can be. You may remember the line of best fit from Schoolyard. This is what a simple linear regression does. A good example would be predicting one's weight depending on their height. Number 2. Logistic regression. Logistic regression is a technique that can be used to make predictions on variables that are categorical. It relies heavily on the knowledge of independent variables but also adds in how often each of the categories has been observed historically. This technique is used for binary data and applies a certain transformation before inputting it into the logistic regression equation. For example, it is possible to use logistic regression to determine whether a student will be admitted or not to a particular college based on their grades, either yes or no, or 0 or 1. Number 3. Decision trees. Decision trees are orderly line that splits and categorizes data. They answer questions to learn the features of your data and give a prediction as well. To demonstrate this, imagine if the question is yes or no to determine a species of bird. The criteria for determining whether it's that kind of bird might be feathers, ability to fly or swim, or type of beak. Number 4. Random forest. Similar to decision trees, random forest is also a tree-based algorithm. If a DT consists of one tree, RF consists of a forest of trees that are supposed to provide better quality decisions that are more accurate. It combines multiple models to make predictions and can be used in classification and regression tasks. Number 5. K-nearest neighbors. K-nearest neighbors don't just group data points together at random. They use statistics to measure how close points are together in order to figure out which ones should be grouped with others. The closer they are to each other, the more similar they are, so these would be put into the same group. An excellent example is when we have a graph that has two groups of data points close to one another, Group A and Group B. When we input a new data point, we tend to classify them into the group they are closer to. Number 6. Support vector machines. Like the nearest neighbor algorithm, support vector machines perform a variety of classification, regression, and outlier detection tasks. It does this by drawing a hyperplane, straight line, to separate all of the data points into classes. The data points that are located on one side of the line will be labeled as Group A. Meanwhile, the points on the other side will be labeled as Group B. For example, if a new data point is inputted, depending on which side of the hyperplane and its location within the margin it is, this will determine which group the data point belongs to. Number 7. Naive Phase. Naive Phase is based on an equation that calculates the probability of one event happening with the assumption that another event has already occurred. To put it in simpler terms, conditional probabilities are the probabilities of one thing happening after another has already happened. It predicts that the probability of each class belonging to a different category will be broken down into percentages, and once the highest one is identified, it's used as an indication of what the class would take in. Number 8. K-means clustering. K-means clustering is a method that uses the idea of clustering to group, or cluster, similar items/data points. You do this by selecting the k-value, initializing the centroids, and then selecting how many groups you want. For example, if there are 3 clusters present and a new data point is inputted, depending on which cluster it falls into, that is the cluster they belong to. Number 9. Bagging. Bootstrapping is a statistical method that assigns new samples to replace missing ones in a dataset. It avoids overfitting by reducing the variance of results. Bagging is also used to reduce overfitting and can work with both regression models and classification ones. Overfitting is when a model fits the training data that it has been given and doesn't give any credit to new data. It's primarily due to the way you train your model and the specific situations it encounters. A random forest is an example of bagging, a technique that does well in these situations. Number 10. Boosting. To make students more successful, the goal of boosting is to provide weaker learners with a strong prediction rule. To find these weak learners, Bayes algorithms can be applied and will generate a new prediction rule for the student. A researcher is inputting data from a random sample and then trains it sequentially by gradually training the weaker model and correcting its predecessor. XGBoost is used in boosting. Number 11. Dimensionality Reduction. Dimensionality reduction can reduce the number of variables, and this reduces the complexity of your model. If you have a high number of features, then it will be more complex and there will be an increased risk of overfitting. To use dimensionality reduction, we start with a dataset containing 100 columns. The number of columns can be whittled down to 20. But first, feature selection is needed because more than one feature may be relevant in certain circumstances, and feature engineering would happen after this when new features can be generated. The Principal Component Analysis (PCA) technique is a type of dimensionality reduction. It has the capability of reducing the number of variables to be considered while maintaining most, if not all, of the explanatory power in these variables. Conclusion. This video was for those of us who want to get a better understanding of machine learning. If you would like a more in-depth understanding of each of them, you can search for more articles about machine learning on Google or find the machine learning books.